Welcome back to another night of algebra class. Tonight we're going to be solving multi-step equations. So let's go over the 5 steps together. If you follow along on your note-taking guide, this is lesson 2.3 on page 32. So the 5 steps of solving a multi-step equation. The first thing I want to do is I really want to get rid of my fractions and my decimals. We don't like these. These aren't friends. So do whatever you need to do to try to get rid of fractions and decimals that are sitting by themselves. These are constants. These are not going to be up against a variable. We don't want to get rid of those just yet. We want to get rid of the ones that are going by themselves. All right, the next thing I want to do is I want to use the distributive property. There's probably going to be situations where you're going to see 4 times 3 plus b. You got to go ahead and factor the 4 through and use your distributive property. Then, once I have a bunch of variables and a bunch of constants, I can combine like terms. All right, once I combine my like terms and I get all my a's and my b's in the same place, then I can look at undoing addition, subtraction, multiplication, or division. So the order in which I do this is important. I want to first look at undoing addition and subtraction. That comes first. That would be something like 3c plus 2f plus 8. Oh, look at this. This is multiplication. This is multiplication. This is a constant I'm adding. So before I even deal with either of these two, I want to deal with this first. And the opposite of addition is subtraction, so I would subtract 8 from both sides. All right, once I've done my addition or subtraction, then I can look at undoing the multiplication or the division. All right, hopefully you have these down on your note-taking guide under key concepts. Let's skip down to an example. All right, let's look at this guy over here. 3a plus 6 plus a equals 90. This one is example 1 on page 32, if you're following along. So let's go ahead and see what you can do with this. Let's look at our 5 steps. The first thing I want to do is I want to get rid of fractions and decimals. Well, fortunately I don't have any, so that part's easy. The next thing I want to do is the distributive property. Well, I don't have any, so I'm going to check that one off. The next thing is I want to combine my like terms. Okay, so now I'm looking for either more constants. I've got 1 constant, but I also have 2 a's. I've got a 3a over here and a 1a over here. So I'm going to end up rewriting this equation so that my a's are beside each other with my constant at the end. Keep your equals in a straight line all the way through. Now I can look at actually combining like terms. Notice that I have 3 a's here and I've got another a here. So what is 3 plus 1a? Well, I end up with 4 a's plus 6 equals 90. All right, I don't have any other a's and I don't have any other constants, so I have combined all my like terms. Now I get to undo addition or subtraction. Well, I have addition going on here. So if this is addition, the opposite of addition is subtraction. So I'm going to end up subtracting 6 from both sides. And what I do to one side, I've got to do to the other. Now my 6's end up canceling out, leaving me with 4a equals 84. All right, next thing I can do is I can undo my multiplication or division. Let's look at 4a. This is the same as 4 times a. So I've got multiplication going on here. The way to get rid of multiplication is to divide. So I'm going to divide 4a by 4 and 84 by 4. My 4's cancel out, leaving me just a, and I get 84 divided by 4, which simplifies to 21. This isn't so bad, is it? All right, now I would like you to do the 2 problems at the bottom of the page on the check understanding. It's on the bottom of page 32 of your note-taking guide. you're going to do the exact same process that we did up here. You're going to go through the 5 steps right here. All right, I'm going to pick a clear copy of the 5 steps for you, and you can continue at your own pace and pause me and unpause me when you're ready to continue. Welcome back. Let's check the first one at the bottom of your note-taking guide. It's 1A, page 32. We're looking at 3x minus 4x plus 6 equals -2. Let's go through our 5 steps again. Do we have fractions or decimals? Nope, that's easy. Do I have the distributive property? Nope. I do have some like terms though. What are my like terms? Hopefully you said 3x minus 4x. So let's look at that. If I have 3 plus a -4x, what does that equal? Hopefully you said 3 plus -4 equals -1. So 3x plus -4x is going to give me -1x plus 6 equals -2. Then I've got to move down. I've combined my like terms. I need to look at undoing my addition or subtraction. Look at the side with your x. That's this side over here. I don't care what's going on over here. I care about this side right here because this is where my variable x is. So what am I doing to x? Am I adding something or subtracting? I'm adding, so I have to undo my addition. In order to undo my addition, I'm going to first subtract 6, and I've got to do it from both sides. What I do to one, I've got to do to the other. All right, but let's look at this now. Now I have this canceled out, leaving me with -1x equals, what is -2 plus -6? Well, -2 plus -6 is -8. I still don't have x by itself. I've got this -1. Am I adding it, subtracting it, multiplying, or dividing it by x? Good, I'm multiplying it. Because I'm multiplying -1 times x, I have to undo that via division. So I'm going to divide this side by -1 and this side by -1. These cancel, leaving me with x equals -8 over -1. What happens when you divide a negative by a negative? You get a positive. 8 divided by 1 is 8. All right, let's just check this now really fast. If I want to check my problem, I'm going to plug this x in back in my original problem for everywhere I saw x. It should look something like this. Notice I put a little question mark above my equal sign. This means I'm checking. I don't know for certain it equals -2. I'm checking to see. So now let's solve. 3 times 8 is 24, minus 4 times 8 is 32, plus 6. Does this equal -2? Well, 24 minus 32 is -8, plus 6 equals -2. Yes, it does. My problem works. Let's look at this word problem at the top of page 33, where you have to apply the basic multi-step equation. Let's see what this is saying here. I need to build a rectangular pen in my backyard for my dog. One side of the pen will be against the house. 2 sides of the pen have a length of x feet, and the width will be 25 feet. What is the greatest length the pen can be if you have 63 feet of fencing? All right, they are giving us something that looks kind of like this. I have a house, and I have a backyard out here where I need Fido to hang out. So I have 2 sides of this pen that are going to be up against my house. So these 2 sides we're going to call x. And then my width down here is 25. And my units that I'm dealing with are feet. I can use a single tick mark to indicate that I'm talking about feet. Okay, so now I need to write some sort of equation for the number of fencing. I know that I have 63 feet of fencing. So I've got 63 feet to work with. And I know that I have these 3 sides. Notice I don't have a 4th side because the 4th side is up against the house. Fido can't escape if my house is up here. So I have x plus 25 plus x has to equal 63 feet because this is all the fencing I've got to work with. All right, so let's go ahead and solve this algebraically. First, I need to get rid of fractions and decimals. Oh, happy day, I do not have any. Next, I have to use the distributive property. Oh, don't have that either. Now I need to combine like terms. All right, if I'm looking here, I have 1x and I've got another 1x. I'm going to rewrite these so these are side by side. X plus 25. Cool beans. I now see very easily that I have 2 x's, which is the same as 2 times x. Add 25. All right, now I need to either undo addition or subtraction. So I don't care what's going on over here with 63. It's by itself, it's good to go. I care about the side with my x. So I need to see what's going on over here. I've got this addition going on that I have to undo. The only way to undo addition is subtraction, and what I do to one side, I've got to do to the other. So I'm going to subtract 25 from both sides. And this is going to give me 38 equals 2x. My plus 25 and my minus 25 equals 0. And 2x plus 0 is just 2x. All right, now what do I have going on? Do I have addition or subtraction? No. I've got some multiplication or division going on. Let's look at the side with my x again. 2x is the same as 2 times x. So I've got multiplication. This is multiplication. I've got to end up dividing. Division is the only thing that undoes multiplication. I'm going to divide this side by 2 and this side by 2. And I'm going to end up having to simplify 38 over 2. But that equals 2's crossed out, just x. All right, let's simplify this guy. 2 goes into 3 once with a remainder of 1. 2 goes into 18 9 times. Now I need to use my units. I need to come back up here and say what units was my x? Well, my x was in feet. So I can say that x equals 19 feet. 19 feet is the greatest possible length that my pen can be if I have 63 feet of fencing. Hopefully you filled out your daily note-taking guide with this problem. If you haven't filled out your daily note-taking guide with this problem, please rewind the video, follow through these steps, and write them down in the boxes in your daily note-taking guide. Copy this problem down on your own paper and let's solve this one together. This one is one where I do have fractions and decimals and it's icky. It's no fun to look at. So I'm going to walk you through how to solve an equation that involves variables in a couple of different spots in your equation as well as fractions. All right, let's first, before I do anything else, I want to rewrite this with my fractions, these guys right here, as coefficients. Well, what does that mean to have a coefficient? Remember that 1x equaled x. 1 is my coefficient for x. It's just a number, usually an integer or a fraction. It is some number beside a variable that's being multiplied by my variable. 1/2 x. Here I have 1/2 as my coefficient of x. It's a good term to know, coefficient. So I'm going to rewrite this with my fractions as coefficients. This one's already done for me. It's 2/3 times x. Plus, I'm going to rewrite this guy as 1/2 times x. Remember, I have this like imaginary 1 hanging out here multiplying by my x. And 1 times x divided by 2 is the same thing as 1/2 times x. Cool beans. This equals 7. Once I have this rewritten, now I want to get my denominators to become the same. So how do I get 2/3 and 1/2 to have the same denominator? Well, hopefully you recognize that I can just multiply the denominators by each other. So I'm going to multiply 2/3 x by 2 2's, and I'm going to multiply 1/2 x also by 3 3's, set it equal to 7. Why did I do that? Because I have to get my denominators to equal, and I recognize that I can make 2/3 into 4/6 and 1/2 into 3/6. Now I can end up adding these guys. But before I could do that, I had to end up multiplying both terms by 1. So 2/2 technically equals 1, and it will allow me to get my denominator that I want. So let's check. 2 times 2 is 4, and 2 times 3 is 6. X plus 3 times 1 is 3, and 3 times 2 is 6, times x equals 7. Phew, that part's done. I still have fractions. Blast it all. Well, at this point, I can combine like terms at the very least. So I'm going to come down here to my 5-step guide and see that I can add my x's. I have 4/6x plus 3/6. And again, these are times x equals 7. 4 plus 3 I can just add across now because my denominators are the same. So I get 7/6x equals 7. Holy moly, still have a bloody fraction, and I still have multiplication going on over here by my x. But I've at least combined like terms, so now I only have this one term to worry about. I'm going to come down here and I've got to undo addition or subtraction. Is this 7/6 plus x? No. Is it 7/6 minus x? No. So I don't have any addition or subtraction. I've got multiplication or division. Remember that when I have a fraction times my variable, in order to get the fraction away from my variable, I have to multiply by its coefficient. And what I do to one side, I'm sorry, not by its coefficient, by its reciprocal. What I do to one side, I've got to do to the other. And now let's look at solving this. Notice that my 6 and my 6 are going to cross out, leaving 1. My 7 and my 7 cross out, leaving me 1. So I get just 1x. Beautiful. Keep in mind over here that this is the same as 7/1. So I can just multiply these straight across. 7 times 6 is 42, and 1 times 7 is 7. Now, I'm not done. I still have to simplify. 1x just equals x, and this is the same as 42 divided by 7, which is 6. Oof, that was a lot of work. Make sure you're writing out all of your steps as we do these. Let's look at one with a distributive property. All right, if I'm looking at this example, it's on example 3 on page 33 in my note-taking guide. I have this situation where now I do actually have the distributive property to work with. All right, the first thing I've got to do, I'm going to go through my 5 steps down here again. And the first thing I want to do is look for fractions and decimals. I'm good there. Next thing is I've got to use the distributive property. I cannot add my 3 until I distribute my 2 through this. So let's do that. If I carry my 2 through x, I'm going to end up getting this 2x minus 2 times 3 equals 8. let's solve this now. I have 2x minus 6 equals 8. Okay, now I need to come down and combine like terms. Do I have any other x's? No, I'm good. The next thing is I need to undo my addition or subtraction. I've got some subtraction going on here, so I need to do the opposite. The opposite of subtraction is addition, so what I do to one side, I've got to do to the other. So I'm going to add 6 to both sides here, and I end up with 2x equals 14. Now, I still have something going on here. Is it addition, subtraction, multiplication, or division? It's multiplication. The only thing that undoes multiplication is division. So I'm going to divide both sides, and I get x equals 7. Awesome. Okay, I'd want to go in and plug it back in to check. So if I take x equals 7 as my answer and plug it back up in here, let's check this. 2 times 7 minus 3 equals 8. Well, I could distribute and say 14 minus 6 equals 8 and check it that way. Or I could solve my parentheses first and use order of operations. If I do it that way, I get 2 times 4 equals 8. Does it check out? Yes, it does. Either way I solve it, I'm still good. X equals 7. Good job, guys. At this point, I'd like you to flip over to page 34 in your note-taking guide, and I would like you to complete number 4 at the top of the page, and I'd like you to complete the 3 check understanding problems at the bottom of that page. I will see you in class tomorrow, and I hope this video helped. When you get to the problems 3, go back into this video and look back at the example problems we solved. Hopefully those will help, and I know you can do this.